Hello, today I will be talking about Lab 3, in which we're talking about the effects of a star orbiting around a black hole, and this is for Dr. Schatz's class. The main concept of this lab is dealing with Newton's universal gravitational law, and this is basically saying that F net equals g, which is the gravitational constant, which is 6.67 times 10 to the negative 11 times the mass of the star times the mass of the black hole, over the radius square, and the radius is referring to the radius of the orbit of the star around the black hole. Everyone was supposed to download a Excel file with different positions of the star's trajectory, and mine gave me about a quarter of a circle, maybe a little less than a quarter of a circle's trajectory around the black hole. So in order to find the radius, I found that it was easiest to use the average speed equation when you're referring to circular motion, and that's normally 2 pi r over the t, and t would be the time in seconds or the period. And I was able to find the average speed from just doing like v final minus v initial divided by 2, and I calculated that from the code's output. My time was 86,400 seconds, which was given to me on WebAssign, and I was able to calculate for r by manipulating that equation, the 1/4 2 pi r over t, to get that r was equal to 4.125 e to the 12th. For that, I think it's important to note that the 1/4 over here is added to this equation because my trajectory of the star was not a full circle. I just was estimating it to be 1/4. When you're finding the mass of the black hole, once again, you're going to use Newton's universal gravitation law, and with that I was able to manipulate that and find that the mass of the black hole was equal to the velocity squared times the radius divided by the gravitational constant. And I got that the mass of the black hole was rather large, and it was 3.789 times e to 38 kilograms. So the first question you need to ask is, what does it mean? So it was asking what is the difference between F net and dp over dt, change in momentum over change in time. I think it's important to know that F net is the cause and delta P is the effect. And a good example of that is when you push a marker, it's rolling because a force is put on it, right? So F net is the cause and the change in momentum over time is the effect. The next thing you need to ask is what if? If the black hole was removed and a different black hole was put in its place, would you be able to find the mass of the star's trajectory if it stayed the same? And no, we would not be able to tell because the path of the star is the same, so we would be calculating the same mass in the end. This is true by looking at the formula, Newton's universal gravitation law, and you can see that you're going to end up with the same mass in the end. In conclusion, we applied Newton's universal gravitation law, and we were able to use the average speed equation to find the velocity and to find the radius to then use for that. And that was pretty much all of the lab. I hope you learned something. Thank you. Bye-bye.